All right, so let's look at the pink section. So for this first one, it says, given that side A is 7 and side C is 25, find all 6 trigonometric functions for angle B. So in order for us to do that, we first need to find out all the missing side lengths. And so let's just label what we know here. We know side A is 7. We know side C is 25. So to figure out side B, we're going to use Pythagorean theorem because this is a right triangle. So remember, a squared plus b squared equals c squared. So I'm just going to say 7 squared plus b squared equals 25 squared. So to find out what b squared is, I'm just going to do this quickly on my calculator because you can just type in 25 squared minus 7 squared. And when you do that, you get 576. Now remember, that's not our value for b, obviously, because b is going to be shorter than 25 because 25 is your hypotenuse. So when I take the square root of 576, we get 24 as your answer. So now we know that side B is 24. So now we can find all the other trigonometric ratios. Now what are those? Well, and again, we're doing this for angle B. This is the angle that we're going to be working with here. So we're going to find the sine of angle B. We're going to find the cosine of angle B and the tangent of angle B. But the other three are going to be the reciprocals. Remember that we have the cosecant function. So we'd have the cosecant of B. We would have the secant of B and the cotangent of B. So let's start out with the sine of angle B. So the sine of angle B would be opposite over the hypotenuse. The opposite leg would be 24. The hypotenuse would be the 25. That's all I got to do. So the cosine of angle B would be 7 adjacent over the hypotenuse. So that would be 7 over 25. And lastly, the tangent is the opposite over adjacent. So that would be 24 over 7. Now remember, the cosecant is reciprocal of the sine function. So that's why I like pairing them up like this. And that way I can just see that the cosecant would be the reciprocal of 24 over 25. So that's 25 over 24. The secant is the reciprocal of the cosine function. So that would be 25 over 7. And the cotangent is reciprocal of the tangent. So that would be 7 over 24. So that's how you do number 1. Number 2. So here they gave us that the sine of theta is 9 over 41. So we need to find the other 5 trigonometric functions. And so first thing I'm going to do is I'm going to draw a right triangle here as a reference. Now we know that the sine, let's say this is theta, the sine is opposite over the hypotenuse. So this would be 9, and then that means this is 41. So just like in the previous one, before I can do anything else, I need to figure out what that missing side would be. So again, it's a squared plus b squared equals c squared. All that matters is that c is the hypotenuse. So we could say 9 squared plus b squared equals 41 squared. Again, I would just take 41 squared minus 9 squared, or 41 squared minus 81. When we do that, we get 1600. And I take the square root of both sides. I get 40 is my length of this missing side. So now we have everything that we need. Now even though they gave us the sine of theta is 941, I'm still going to write that down. So we have the sine theta, cosine theta, and the tangent of theta. And then we also have the cosecant of theta, the secant of theta, and the cotangent of theta. And the sine of theta they gave us, that's 9 over 41. Okay, so the cosine. So the cosine of theta would be the adjacent over the hypotenuse. So that's going to be 40 over 41. The tangent would be the opposite over the adjacent. So it would be 9 over 40. And so these would be the reciprocals again. So this would be 41 over 9. This would be 41 over 40. And this would be 40 over 9. Now for number 3, all we have to do is find the missing side length. And so we're just trying to find out what the value for x is. Now x is across from the right angle, so that means x is our hypotenuse. I also notice that since it's a right angle, SOHCAHTOA, those ratios, those trig ratios would work. So it doesn't matter which angle we use. We could use the 49-degree angle, or we could use the 41-degree angle. And depending on which angle we use would determine if we use sine, cosine, or cosine. But I'm going to use the 49-degree angle. So that means that this would be the adjacent leg to the 49-degree angle, and this would be the hypotenuse. Now just as a side note, if we were going to use the 41-degree angle, if we were going to do that one instead, now this would be the opposite leg, and this would still be the hypotenuse. So if we were going to use 41 degrees, we would do the same process, but with the sine of 41 instead of what I'm going to do here. Needs to be the cosine of 49 degrees equals the adjacent, which is 35 over the hypotenuse, which is x. So we're going to multiply both sides by x. So I get x times the cosine of 49 degrees equals 35. So now I divide both sides by cosine of 49. So I take 35 divided by the cosine of 49 degrees. My eraser's not working here, so let me just do this. All right, so cosine of 49 degrees. And when you do that, you get 38.1 approximately as your answer. So side x would be about 38.1 or 38 units. All right, let's look at this last one. So this last one, it says a hot air balloon is flying at an altitude of 2,074 feet. If the angle of depression from the balloon to a house on the ground is 35 degrees, how far is the house from the pilot? All right, so we get to draw a picture here. So let's say this is my hot air balloon. And this is the house. Okay, now it says a hot air balloon is flying at an altitude of 2,074 feet. Okay, and it says the angle of elevation from the balloon to the house is 35 degrees. Now here's the deal. When you're in the balloon and you're looking straight across and then look down at the house, this is the angle of depression. So that's the angle that's 35 degrees. Now that's outside of the triangle. So remember that since this horizontal and this horizontal are parallel to each other, that means this diagonal here cuts that angle. We call that a transversal. So that means the angle of depression and the angle of elevation, which would be here, are the same value. All right, so now I can use that information to figure out this side. So we're trying to figure out how far away the pilot is from the house. So this 2,074 feet, that's opposite that angle, and this would be the hypotenuse. So it would be the sine 35 degrees equals the opposite, 2,074 feet, divided by the hypotenuse, which I'm trying to find. So we multiply both sides by sine, or by x, and so we have x times the sine of 35 degrees equals 2,074. So to find out what x is, we would divide by sine of 35. And when you do that, when you take 2,074 divided by sine of 35, we get 3,615.9 feet. So that's the pink section. So hopefully that answers the questions you might have had from that. And if you don't have any other questions, you can move on now to the next video.